So in this video we will be seeing how to check if the process is being under the debugger or not. So we can use this function is debugger present, so it will return boolean value whether the process is being debugged or not. So it's very simple one. You can this resides in the kernel32.dll. You can just simply copy this one. So I can go and simply print this one. If I go and run this, and we will get the value true because this process is being run under this Visual Studio debugger. The main problem with this function is many EDRs will try to monitor the API calls, and if there is any call to this function, then our process will not be executed. So this malware will try to first detect whether the binary is running under the debugger or not. Whenever the malware finds out that it is running under the debugger, it will simply exits the code. So you can just simply put an exit if the debugger is present. If there is no debugger, you can normally run the code. Actually this function will try to fetch the information from the process environment block. So this is the structure, and Windows kernel will initialize all of these values. So there are not many unknown values, so there are many unknown values here, but the third byte is being debugged. So you can see the first one is reserved 2 bytes and the third byte is being debugged. So we can get this pointer to the structure using this NT query information process. This resides in the NTDLL. So we can get the process information, and what type of information we need to retrieve depends on the second parameter. The first parameter is the process handle, and the second parameter is type of this process information class, and this is normally an integer. So we'll be passing this process basic information. And here you can see this is the structure. All of these are normal pointers, and here you can see the second member is the pointer to this PEB structure, and the third parameter is the structure this function will fill. You can see the out parameter, and the next one is process information length. So we will be sending this structure length, and the output is the return length. So let's go and import this one. Also, if let's go and open this in our file explorer, and if I go and run this normally under normal command prompt window, I get false because there is no debugger. It's normal process. But when I run under this Visual Studio, the debugger will run this program. So this NT status is an integer. So the first one is the pointer, which is the handle to the process, and the second one is process information class, the type of this class. You can see the basic process basic information. We can just say integer, and the third one is the pointer, and the next one is the length. We can say this as uint, and output is the variable to the variable of the the length of this structure. So we have defined the function. Now I have already copied this process information class, that is process basic information structure. So here you can see all of these are the pointers. So we can go to this pinwork.net website. Here you can search for process basic information. Here you can see there is also the signature, and here you will have this enum containing all the values. So let's create the structure member. And we need to also create uint length of this one. And we need to convert this into uint. And we can get the current process handle using this process dot get current process dot handle. So we'll be passing this proc handle, and the second one is the process information class, that is 0 process basic information, that should be 0. And the third one is the pointer. Let's allocate the size to hold that much amount of structure. So I think we can say size so let's pass that pointer here, and the process the structure length of the process basic information, that is size, and the output the length should be stored into a variable. Okay, I think we are good to go. And after that we will be getting the pointer to this structure. So what we need to do is we need to convert this pointer to structure, PBI PTR and the type of basic information. So we have created this one. Let's comment this. So we got this structure. So PBI is the structure. Now we can say int PTR, peb PTR. So that is the pointer to the PEB structure. We can say PBI dot PEB base address. So we got this PEB PTR pointer to this structure. So all we need to do is we need to just move 2 bytes forward and retrieve the content. So we can say marshal dot read byte. So we can use this function to read the byte at the particular address. So we can say PEB PTR plus 2. So that will gives us the value of this being debugged value. So we can just print this one. So now we should get the value 1, and you can see we got the value 1. Now if we go and run this in the PowerShell, we should get the value 0. So we are good. Now we can just write some code. If is equals to 1, debugger is present, quitting. No debugger is present. So let's go and run this, and you can see the debugger is present, and if you run this, there is no debugger. So this is one of the technique to find whether the process is under the debugger or not. We can also pass the process handler of another process as well. So this technique is also used by the game anti-cheat engines. You can see this is the Valorant game, and this Valorant game has this Riot Vanguard, that is the anti-cheat engine used by this Riot games. So this Valorant, if you try to just open the debugger and open this process, and if you run this, and this Riot Vanguard will be in the background, and it will ban you from the game. So it will not only ban you from the game, it will ban your hardware ID. So that means you cannot play this game under this computer. So you need to buy another computer to play the game. So this is the best anti-cheat engine up to now from this Riot games, Riot Vanguard. So that's why you need to just Google before if you are attaching any game to the debugger. If it's FPS game, if it's a single player game, it's no need to worry. If it's a multiplayer game, so then you need to be some more cautious about debugging.